Hello students, myself Arpita Bhatia. Today we are going to study CPU schedule algorithm in operating system. Basically, why CPU scheduling is required? Because if more than one processes are in the ready queue, then how will decide that CPU is allocated to which process? There are two types of algorithms, preemptive and non-preemptive. So in preemptive algorithm, if more than two processes are in the ready queue, then we will decide which process is allocated to the CPU according to their priority and burst time or according to their arrival. In non-preemptive algorithm, the process is not removed forcefully from the CPU until and unless its termination has been done. So here we are going to study about the FCFS scheduling algorithm. It is non-preemptive scheduling algorithm. Here 5 processes are there. Their arrival time is given, their burst time is given. Okay. Now I will decide that which process is going to execute, or we will allocate CPU to which process according to their arrival. Okay. The full form of FCFS is first come first serve. So basically we will decide about with the help of their arrival time. We will draw the Gantt chart. Okay. Here at time 0, which process come? At time 0, P2 comes. Then we will allocate CPU to P2. For how much time? For 1 unit of time. Okay. Now, this process has been executed. Next. Now, at time 1, which process comes? No process comes. So, CPU will remain idle for 1 unit of time. At time 2, which process comes? In the ready queue, P1 and P3. So, there is a tie in the arrival time. So, how we will decide? We will decide according to their writing order. Which process comes? P1. It will run for how much time? For 2 unit of seconds. Next, which process is in the ready queue? This is P3. For how much unit of time it will run? For 3 unit of time. Now next, P4 and P5 are in the ready queue. P4 will run for, its arrival time is less than P5. So P4 will run for 5 unit of time. Next is P5 for 4 unit of time. Okay. Here, completion time, CT means completion time, TAT means turnaround time, WT means waiting time, and it is response time, RT. Completion time. Completion time, how much time a particular process has taken to complete its task? P1. For P1, the completion time will be 4. For P2, completion time will be 1. For P3, completion time will be 7. For P4, completion time is 12. For P5, completion time is 16. Now, turnaround time. Basically, turnaround time is completion time minus arrival time. At how much time it has been arrived and how much time it has taken to complete this task. Their subtraction will be turnaround time. So, for P1, it's 2. For P2, 1. For P3, 5. For P4, 9. For P5, 12. Okay. Now, waiting time. How long process has been waited so that CPU has been allocated to that process or its task has been completed? Turnaround time minus burst time. For P1, 0. For P2, 0. For P3, 2. For P4, 4. For P5, 8. Okay. Next, response time. First time response has been given to a particular process minus arrival time will be taken as the response time. For P1 first time response it has given at the time interval 2 and arrival time is 2. So 2 minus 2, 0. For P2 first response has been given at time 0 minus arrival time 0, 0. For P3, First time's response has been given at time unit 4 and arrival time is 2. 4 minus 2, 2. For P4, first time response has been given at 7 unit of time and arrival time is 3. 7 minus 3 is 4. For P5, first time response has been given at 12 and arrival time is 4. So 12 minus 4 is 8. How can I verify that the numerical I have solved or the response time, waiting time and turnaround time, all these times has been verified through, check this, waiting time for non-preemptive scheduling algorithm, waiting time will be always equals to response time. If these two are equal, then your numerical is correct. Okay, basically we have solved first come first served algorithm with the help of non-preemptive. Now here we'll go with next algorithm, shortest job first. Basically there are two algorithms, shortest job first and shortest remaining time first. Okay, if numerical has been given like this in the exam, in shortest you have to solve the following with the help of shortest job first, then it means you have to solve this algorithm or this numerical by using non-preemptive scheduling algorithm. If in the exam it comes solve shortest job first with the help of preemption, then it means shortest remaining time first. As I have already told you that difference between non-preemptive and preemptive is that if in non-preemptive we cannot forcefully remove a particular process from CPU until and unless it has completed its execution or it has been waiting for a particular resource. Okay, in preemptive algorithm we can schedule algorithm on the basis of their priority, on the basis of their arrival time or on the basis of their burst time. Now here it comes shortest job first. Okay, here we'll solve numerical with the help of looking burst time. A process having least burst time will assign CPU first, and if there are two or more processes having same burst time, then we will break the tie with the help of FCFS, first come first served basis. Now we'll start from this. Here burst time is given and arrival time is given. Now as I have told that assign CPU to that process having less burst time. So no need to assign that P1 and P3 has least burst time, so we can assign CPU that. But see arrival time. Arrival time is 2 and 4. So can CPU remain idle for the 2 units of time or 4 units of time? No. We will at first time to start allocation to the CPU, we will start with the process arrival at 0 unit of time. No need to look at that process how much burst time it has taken. Okay. So first we will start with P4. Why? Because it has arrival time 0. CPU cannot remain idle for 2 units of time or for 4 units of time. Instead, its burst time is large among all the processes. So at P4, at 0, P4 process will come and it will run for how much unit of time? For 6 unit of time. Okay. Now P6, at 6 unit of time, which process has come? In the ready queue, all process has come. See, P1 has come at 2 unit of time, P2 has come at 1 unit of time, P3 has come at 4 unit of time, or P5 has come at 2 unit of time. So, okay, all the processes has come. So now we'll decide to allocate CPU to which process having least burst time. P1 and P3 has least burst time. Okay, but we'll allocate to CPU to which process? To P1, because there is a tie in the burst time. So we will break the tie with the help of FCFS. P1, we will allocate CPU to P1 process. Okay, P1, it will run for 1 unit of time. Now, now we'll execute P3. It has burst time 1. Now, two processes are in the ready queue, P2 and P5. Which has least burst time among these two? P5 has least burst time, 3 units of time. It will run for 11 units of time. Next, which process is remaining in the ready queue so that we can allocate CPU to that process? It is P2. It will execute for 5 units of time. Okay. So basically, if 2 or more processes has same burst time, then we will break the tie with the help of FCFS, first come first served basis. As it is non-preemptive scheduling algorithm, so we cannot remove process forcefully from CPU until and unless its execution has been completed, it has been terminated. Now completion time. Completion time means how much time a process has taken to complete. Okay. For P1, how much time is there? 7 unit of time. For P2, 16. For P3, 8. For P4, it's 6. For P5, it's 11. Okay. Next, turnaround time. Turnaround time, basically a process has arrived and completion its task. This time taken has shown as turnaround time. At how much unit of time it has came and it has completed its task, so how long it has taken. So turnaround time basically means completion time minus arrival time. So for P1 it will be 5, for P2 15, for P3 4, for P4 6, for P5 9. Right? Now waiting time. How much time a process has assigned is ready in this placed in the ready queue and it has been waiting for the CPU for allocation. It will basically the turnaround time minus burst time. For it1 4, for P2 10, for P3 3, for P4 0 and for P5 6. Okay. Now response time. Response time means first time a process has given the response minus arrival time. Why arrival time? Because it was placed in the ready queue already, but for some reasons we are not allocating CPU to that process. So response time for P1 first time response has given at 6 unit of time. For P1 6 minus 2 4. For P2 first time response has given at 11 units of time. So 11 minus 1 10. For P3 first time response has given at 7 unit of time. So 7 minus 4 it will be 3. For P4 first time response has given at 0 unit of time minus arrival time it will be 0. For P5 first time response has given at 8 units of time and arrival time is this 6. So my numerical has been verified by this. Waiting time is equals to response time. So okay, for non-preemptive algorithm waiting time will always be equals to response time so that you can verify that you have solved numerical correctly. Okay. You can also verify shortest job first algorithm, non-preemptive algorithm by this total burst time. This total burst time will be equal to this completion time. See, 1 plus 5 6, 6 plus 1 7, 7 plus 6 13 and 13 plus 3 is 16. So you can also verify by using this. If you have asked in the exam about calculate total turnaround time, okay, total turnaround time, then you can solve by using this. Or if asked about average turnaround time, then simply add turnaround time of all the processes and divide it by the number of processes. Okay. If you have asked in the exam about average waiting time, then you can also solve by using this formula, total waiting time divided by number of processes present. Okay, here total turnaround time will be 15 plus 5, 20, 24, 30 and 39. Here total waiting time will be 14, 14 plus 3, 17, 17 plus 6, 23. Okay. Now, average turnaround time will be 39 divided by 5. 7.8 units. Okay. Now, for average waiting time will be total waiting time divided by number of processes 5. 4.6 units of time. Okay. Thank you.